Unit 6, Lesson 7, Trig Applications. An archaeological team is excavating artifacts from a sunken merchant vessel on the ocean floor. To assist the team, a robotic probe is used remotely. The probe travels approximately 3,900 meters at an angle of depression of 67.4 degrees from the team's ship on the ocean surface down to the sunken vessel on the ocean floor. The figure shows a representation of the team's ship and the probe. How many meters below the surface of the ocean will the probe be when it reaches the ocean floor? Give your answer to the nearest 100 meters. So what we're going to do is drop a perpendicular from the ship down to the ocean floor. This is going to create a right triangle. And we're looking for this value right here, x. And we have two parallel lines, one at the ship on the ocean surface and one down on the ocean floor. So this angle of depression is equal to the angle of elevation. So that goes inside here. So with regard to that angle, we are looking for the opposite side, and we know what the hypotenuse is. So that's the sine function. So sine of 67.4 degrees is equal to the opposite x over the hypotenuse of 3,900 meters. Cross multiply. Go ahead and put that into your calculator. Round to the nearest 100 meters. So that's going to be rounded to the left of the decimal point. So just to refresh your memory on decimals, so this spot is called the ones, this spot is called the tens, and where the 3 is the hundreds spot. So the value that we're looking for is 3,600 meters. So how many meters below the surface of the ocean will the probe be when it reaches the ocean floor? 3,600 meters. Example 1. As shown below, a canoe is approaching a lighthouse on the coastline of a lake. The front of the canoe is 1.5 feet above the water, and an observer in the lighthouse is 112 feet above the water. This one's a little bit more difficult, and you really have to think about it in order to set it up. At 5 o'clock, the observer in the lighthouse measured the angle of depression to the front of the canoe to be 6 degrees. So we know that alternate interior angles are congruent, so the angle of elevation is also 6 degrees. That goes inside here. Really, it's way down in here. 5 minutes later, the observer measured and saw the angle of depression to the front of the canoe had increased by 49 degrees. Determine and state to the nearest foot per minute the average speed at which the canoe traveled toward the lighthouse. So we have to consider and take into account that the canoe is 1.5 feet above the water. So that means that's going to affect the entire height of the lighthouse here. So we're looking for this distance here. That's going to be x. We have the angle across from it as 49 degrees. So we have x over sine of 49, using the law of sines here, is equal to 112 minus 1.5 over the sine of 6 degrees. Okay, so x is equal to, the difference between 112 and 1.5 is 110.5 times the sine of 49, all divided by the sine of 6 degrees. Okay, so after putting this into your calculator, you're asked to round to the nearest foot. So we're going to put in 798. And they want to know, to the nearest foot per minute, the average speed at which the canoe traveled toward the lighthouse. So we're going to take 798 and divide by 5, because it's 5 minutes later, and we get 160 feet per minute. And that, my friends, is the final answer. We're skipping this problem. I don't like the way that it's proposed, and it's not a good picture. It leads to some ambiguity in the way that things are phrased. This should be more straightforward, so this is being omitted. So please complete the associated homework at this time.